Working with Tinkercad. This lesson introduces Tinkercad, a free online tool for creating and simulating electronic circuits. You'll learn how to start a simulation, edit components including their properties, wire components together to form circuits, add various components to your designs, and specifically, how to use a breadboard within the Tinkercad environment for prototyping electronic projects. Introduction to Tinkercad. Tinkercad is a free web app for 3D design, electronics, and coding. You can access Tinkercad at www.tinkercad.com. The Tinkercad circuit's user interface is divided into key areas. The workspace is the main area where you place and connect components. The work plane is the grid on which components are placed. The Components panel provides a library of electronic components to choose from. The navigation bar offers options for setting title and navigating between circuit view, schematic view, and component list. The toolbar provides tools for rotating, deleting, and connecting components. The Blocks panel and Code Editor allow you to program your circuits, with the Blocks panel using a visual block-based language and the Code Editor using text-based code, like C++ for Arduino. The Start Simulation button initiates the circuit simulation, and the serial monitor displays serial output from your code. Start simulating. To start simulating, if you want to simulate pre-made designs, check out the starter circuits, which you can find and select in Starters tab by clicking the components. Click on the Start Simulation button located at the right of the toolbar. Use the simulator to test your circuit design at any time. Editing components. To edit component properties, click on a component. An inspector, a pop-up window appears. In case of an LED, you can change the color of the LED to red, yellow, and green, respectively. Wiring components. Bring a 9V battery and breadboard on the work plane. To wire components together to create electrical connections, hover over the red terminal of the 9V battery labeled as plus terminal and click it to add the wire. Hover over the breadboard, the white board for electronic component, and click on the hole next to the plus symbol to complete the wire. Click on the wire and change the color to red in the inspector. Keyboard shortcut 2. Hover over the black terminal of the 9V battery labeled as terminal and click to add the wire. Hover over the breadboard. Click on the hole next to the dash symbol to complete the wire. Click on the wire and change the color to black in the inspector. Keyboard shortcut 1. Click on the Start Simulation button. Adding components. To add component in a circuit consisting of 2x 1.5V batteries and a DC motor, to make it an interactive motor controller. Click Components panel, then search and add a photoresistor on your workspace. Click on the photoresistor and add it to your circuit below the red wire. Rotate the photoresistor by clicking the rotate icon or pressing it on your keyboard so that the pins are facing up. Delete the existing red wire by clicking on it and then clicking the trash icon. You can also press delete on your keyboard. Wire the photoresistor so that one end is connected to the positive end of the battery and the other is connected to terminal 2 of the motor. Click on the Start Simulation button. Introducing the breadboard. Breadboards are a useful tool for prototyping with electronics. With it, you can connect many components together. It contains the thin metal connectors under the top layer of plastic, which carry electricity between sockets. Breadboard full size. A full-size breadboard contains 63 rows, 10 columns, and 2 pairs of power rails. Breadboard small. A half-size breadboard contains 30 rows, 10 columns, and 2 pairs of power rails. Breadboard mini. A quarter-size breadboard contains 17 rows, 10 columns, and 2 pairs of power rails. To connect electronic components to breadboard power rails, please follow the steps outlined below. Click Components panel, then add breadboard, 9V battery, resistor, RGB LED, and push button to your workspace. Hover over any of the holes in the column next to the plus symbol on the breadboard and notice how the entire column turns green. This means that all of the holes in this column are connected to one another. Connect the plus and power rails of the breadboard to the positive and negative terminals of a 9V battery, respectively. Add an RGB LED to the breadboard by placing it in E13, column E, row 13, and connect its cathode to the power rail through a 480 ohm resistor by placing one leg of the resistor at D14 and the other at D18. And connecting A18 with wire with power rail. Add a push button to the breadboard by placing it on E1 and connecting one of its legs to the plus power rail through the wire from plus power rail to A1. Connect the other leg of the push button to the red pin of the RGB LED by connecting D3 with wire to D13. When the push button is pressed, the LED should turn on and change color. Similarly, you may add two more push buttons for green and blue pin.